the work that you'll see that I have done in Mexico is definitely influenced by Professor Fernandez's work. Please click, please. There's more of Professor Fernandez's work. And please click. Please click. These are on the campus of Oaxaca University in Oaxaca, Mexico. One more. Okay, that's probably the first time I met Dr. Fernandez, Professor Fernandez, and he's pretty old there. And when I did arrive in Mexico, which he invited me to, he was fairly ill and no longer at the university. So I headed for the mountains where I knew some people, where I would be more free to construct the prototype of the first building I ever built out of ferrocement. And I decided to do it with hand tools, trying to create a system that worked no matter where you were, if you needed to build houses under any conditions. It's called Intact Structures, and I have a thought that there's some kind of a phoenix rising out of the ashes in the 21st century for ferrocement. And if through collaboration, perhaps my design and others that I'll show you, we can actually create a code-conforming ferrocement building which, as far as I can tell, doesn't exist in the world. There are certainly ferrocement buildings, as you saw, you can click please, like Professor Fernandez's buildings, but they were not code-conforming. They were free-form, and there's many of them. But that doesn't work in a municipal area or for the masses of people that would need houses. Okay, this shows, this is the building that I constructed in the mountains, under construction. That's a rendering of what it could look like, and a client of mine in Florida, in the US, asked if I could make a rendering that showed the same structure, but with a different look. And there it is, which is cultured stone and a tile roof over the ferrocement. And please note, it's an interesting thought I came up with when I was doing this one for them, that the gutter form could be used as a planter around the windows for them to make it look more cottage-like. But then I realized, of course, that people in a disaster, say a flood zone, the land would be useless and they couldn't grow crops, perhaps for a very long time. And they would need food right away rather than wait for food trucks. You could put good earth in the planters around your whole house and always grow lettuces and things like that. So you'd have a food source. And I'm sure when you have no food, it'd be very convenient. This is the one on the right is in my yard on Staten Island, New York, and I thought it was just a nice photo of a covered with snow. And this is a rendering of the beginning of what it could look like. I see this, and originally I designed it as being 150 feet in diameter, and some kind of a, I called it the initial of a hope, some kind of hospital or trauma center. I'm going to try to describe, and I think I can if this works, the simplicity of constructing these buildings. They're very tent-like. So, well, that's the floor plan, and that's another rendering of what it could look like with a finish on it. Please click. Another rendering. Please click. These are sketches that I try to make an Asian intact structure to make the buildings look different. And I'll probably be able to prove to you or show you how the components, which there are about 5, all make all these designs and shapes that you're seeing. Please click. I don't know if it's obvious, but these renderings are basically the shape of the building that was built in the mountains in Mexico. The components, which you can see in the frame right there, more or less just go around the perimeter of any footprint or foundation that you made, and you follow it as you see there. Those buildings could be, I speak in feet, so they could be 100 feet long, like either garden apartments or factories or schools. And they could have inner courtyards for safety in very dangerous areas of the world where there's so many refugees now, where they just fence them in and they're all unprotected. Perhaps these are solutions to hundreds of thousands of people with nothing for a year. But they do erect like tents. And please click. Now this was published in Ferro 9 in Singapore, the University of Singapore. This is a ferrocement retaining wall, and I did build a prototype on Staten Island in New York, small one. But then I realized that because I built it without a footing, I call it I don't want to actually call it a dead man. That block of cement in the back, holding it, and that's a geotextile on top of a ferro cement. Well, there's concrete beams coming out, and then there's a ferro cement slab, and that's a ferro cement wall. But there's a geotextile, so you get two irrigation potentials. When it rains, if you had a terrace farm on the top, it would come down, hit the geotextile, so you had one farm. It would then go to the tank, because the geotextile would capillary it back to the tank, and then you could irrigate or supply water to the valley below that had been, in the past, a flood zone or a mudslide zone. So I'm trying to reclaim land. I hear that land's so that's half the cost of the building. Perhaps in areas, I'm sure only rural areas, perhaps you could be given land that was more or less deemed useless and make it useful. There's another product that you're going to see from a company from Argentina that is also a ferro cement product that would also assist that, culverts or gabions. Let's bring it along, please. The interesting thing with ferro cement, and this is just a recent, I probably knew it, but it was probably subliminal, that it's morphogenetic. In other words, you could show up at a site with exactly the same material, not many different types of material, rebar, 6x6 wire and wire mesh, Portland cement, and an aggregate. And you could produce tanks, culverts, pipes, houses, retaining walls, with the same thing, the same truck, everything's the same. That's morphogenetic, it's the same form. It's a pretty interesting approach. Please click, get the call. I mean, I don't want to read all this for you. Please click. Thanks. Here. Okay, this is a very interesting man. I'm actually a designer constructor more than a ferro cement company. Obviously, I built a house in Mexico and that wall, but these men that I'm about to show you, or this company, he's been in the ferro cement business for 30 years, and he came to my yard and he decided that I was onto something, and he's working with me. And we intend to do two versions of that building system. One is precast components, and one is the way I built it in Mexico. Because he's a precast expert. And there is a man, J.A. Desai, who's a maestro of ferro cement in India, in Mumbai. I did go there twice, and I did study his work. Certainly I don't know what he knows. Carlos Giswin knows a lot about it. And he has these products, as I said, for 30 years in Argentina. This would dovetail into reclaiming land that we could get for nothing, perhaps. In areas, in the rural areas, there may be land nobody cares about ever, because it never worked. It was always washed out, and you could stop that from happening, which is the way most of the modern world was built. Okay. Anyhow, so he has culverts, and he has, go ahead, please. Go ahead, please. Pipes. Please. Gabions, which I found very interesting. Please click. There they are. For stopping erosion and creating circumstances that I'm speaking about. And Carlos is ready, and he's asking for work, in a way. Argentina's got an economy that's having trouble. He makes pontoons also, and I saw somewhere in one of these presentations about floating houses in Thailand. And somebody was very interested in that in the Philippines. By the way, what you saw in the beginning could be very good evacuation centers. And they are, they're very sought after. Things that would be structural after a disaster hit, where you could bring people and they would be self-sustaining. Okay, please click. There's this floating houses. One more, please. One more. More. I think it's over. I think that's it. Okay. Hopefully it was sufficient enough to communicate.
Maybe
Oh yeah. This will show. This will be quick. It's almost like an AutoCAD. It's my version of piecing together an AutoCAD. And also, if I had time, which I don't, that circle is what creates all the points that create that building. There's no measuring. There's no nothing. It's self-forming in a way. Okay, that's one of the components, and you set them up as that. Go ahead, and you'll see. That's what I call, I have funny names for things, but it's 5 18-degree angles that create 90 degrees that shoot out to create the ellipsoid. But I call it a turkey tail, because it'll look like a turkey in Mexico. Okay, next please. Okay, that's it. If I had time, that would tell you it's a 5-foot radius. Say this building's 20 foot, so the circle is 10 feet in the center. And it's hard to describe it quickly, I can't do it. Anyhow, you put that ridge up, and those things connect to those points. All of these points to build this building are built into the building. There's no layout. You just run these things to the components, have the points in them. They're laid out already. Once you level them up and put them up. The beam up there is that beam up there, you fabricate that just like you see, and then you stake a circle, and you walk around your tie, and now you have a circular beam that you place on top. Go ahead. There it is. And that did you get a chance to do the last one? No? Okay. Anyway, the one you saw in the beginning that was with the snow, and also had the cultured stone on it, was the way this would look when it was finished.